To determine whether a function is increasing or decreasing at a particular point or over an interval, you can use the first derivative of the function. The first derivative provides information about the slope or rate of change of the original function. Here's how you can determine whether a function is increasing or decreasing. Step 1. Find the first derivative of the function. Take the derivative of the original function with respect to the independent variable, usually denoted by x, to obtain the first derivative. Step 2. Identify critical points. Critical points are the points where the first derivative is equal to 0 or undefined. These points could potentially be the locations of local extrema, minimum or maximum, or points of inflection. Step 3. Analyze the sign of the first derivative. In the interval between critical points, check the sign of the first derivative. A. If the first derivative is positive in an interval, the original function is increasing in that interval. This means the function is sloping upwards as x increases. B. If the first derivative is negative in an interval, the original function is decreasing in that interval. This means the function is sloping downwards as x increases. C. If the first derivative is 0 or undefined at a specific point, it indicates a potential critical point, which may be a local extremum or a point of inflection. The first derivative test. The first derivative test is a method used to determine whether a critical point corresponds to a local minimum, local maximum, or neither. It uses the sign of the first derivative to make this determination. 1. If the first derivative changes from positive to negative at a critical point, it indicates a local maximum at that point. 2. If the first derivative changes from negative to positive at a critical point, it indicates a local minimum at that point. 3. If the first derivative does not change sign at a critical point, remains positive or negative, or if the first derivative is undefined at that point, the test is inconclusive, and the point may be a point of inflection or neither a minimum nor a maximum. By applying the first derivative test, you can determine the behavior of the function around its critical points, identifying whether they correspond to local extrema or points of inflection. Thank you.